Thank you everyone for participating this afternoon. As you are well aware from the blog post, we are planning to have an informative session regarding guidelines on close proximity operations, the work that has been done, and I will guide you through what has been done at ISA level, where are we, and what are the next steps in terms of the activity. Most of you might have came in contact with us during the years since 2019 when we started the working group. Again, my name is Adina Cotuna. I'm a system engineer at ISA, and I'm also involved in the activities related to close proximity operations and close proximity operations working group. Just to give you even if I'm not part officially of the core team of the Clean Space, I have this slide here in order for you to be a bit aware, basically which type of branch and which type of mainstream from the Clean Space point of view we are in today with this activity for close proximity operations. Basically, it's related to in-orbit servicing, active debris removal branch, and mostly targeting rendezvous, maybe capture. This is basically where we are standing today in terms of Clean Space. Of course, from all the other webinars, you also might be very well aware that there are also other branches of Clean Space, eco-design, management of the end of life. And for sure, you have been or not involved in other webinars, but just keep an eye on the blog posts and on the web page, because you're going to be informed of the other webinars that are going to take place. So if we dive into the topic of today, basically, I would have two main objectives, and let's see if by the end of the session I will be able to make myself understood and clear. Of course, if you have any questions, don't hesitate to post on the chat, and we will also address more questions towards the end of the session. Unfortunately, I'm not able to see the questions live, so if there's something really urgent, just make some more in the chat, a comment, and we will maybe address it as the questions come. So in terms of objectives, I will talk a bit about the fact that we started drafting some guidelines for close proximity operation and why it was so much needed. And I will also explain what types of technical recommendations we have in the first draft issue of the technical guidelines. And also I will talk a bit about the approach and the methodology that we use in order to derive these technical guidelines for close proximity operations. In terms of the background, basically why we started was because there was this worldwide interest in execution of rendezvous, proximity, and capture operations for in-orbit servicing, and also because industry came back to ISA quite with some missions, and actually they were asking for guidance in performing this type of operations, and it was an obvious need that we had to start discussing about this and to start to move forward in order to also support industry, and also in order to also gather the knowledge and have a vision about this type of services. So historically, in-orbit servicing missions have involved humans in the loop activities. If we think about ISS operations, they all had the humans in the loop. So, of course, there are different types of skills and also of measures of actions that are needed in order to actually perform this type of operations. But future in-orbit servicing missions are likely to be more commercially driven. It already started with quite some companies that are initiating all types of in-orbit demonstrations for this. And basically, this brought into the attention of worldwide companies that basically these are complex systems, and the previous human in the loop activities are actually replaced by this type of non-human rated missions. There's a clear knowledge gaps, and we need to actually understand what needs to be done for rendezvous and capture. And also there is a lack of technical requirements, verification methods, and also validation. The satellites are also unprepared for this type of activities, also for repair, refueling, and tagging. And there's a more and more obvious commercial interest for this type of operation. So these were the primary reasons why we started to look into in-orbit servicing and actually rendezvous proximity and capture operations. Of course, the work has already begun worldwide, and there are various missions that are, are, um, are are proving that this need is actually real, and that the things are moving very fast in the space domain, and that something needs to be done in order also for this type of missions to be to create a safe environment, to actually protect whatever space assets we have, but also to give the opportunity for the insurance and operators to do the proper job in order for the safety and sustainability of such missions to actually be real, and give the confidence that what we're doing is sustainable on the long run. These are just a few examples, so that we see that is an activity that already has a lot of interest worldwide. What we did at since 2017, actually, we basically started discussing with all types of industrial partners, mostly European, in order to which came to ESA and actually asked guidance in order for them to go on with feasibility sessions and actually with also implementation of such missions. In 2018 at ESA, it was a working group that was internal, so basically with ESA experts, that was created. And after quite some work, it was almost a year of meetings and technical discussions, only technical discussions, basically a technical document on guidelines on safe rendezvous and proximity operations was created. And basically this document was made publicly available at the workshop at ESTEC, the Clean Space Industrial Days, actually. And whoever was interested was able to actually have a look at the document and also provide feedback, because that was also good for us internally to understand if the technical guidelines and principle and best practices that we try to highlight there make sense and they're actually implementable. In parallel, of course, we are also aware that CONFERS, which I'm gonna mention a bit also later, it started the international coordination and collaboration with various companies in 2018. And since 2018, actually since October 2018, ESA was an observer at the CONFERS workshop, and also we presented the guidelines on safe proximity, safe rendezvous and proximity operations at the workshops of CONFERS. But of course, as observers, we did not participate in all the other meetings that were basically dedicated to the members. But they were aware about what we were doing, and also we were aware about the discussions that were happening. I have also to mention that basically the work that we did at ESA working group level was a bit different than the work that CONFERS is doing, because basically what we are targeting is mission safety and sustainability on the long run. CONFERS is at that point at least was targeting also more mission success. So the point of view was a bit different, but of course they were also in some cases discussing some technical guidelines and best practices mostly. Based on the feedback that we got after having this internal work done, it was clear that it was needed to have also more discussions on the technical guidelines and requirements, but also to involve more and more European stakeholders in order to actually have a type of safe environment where we can share ideas, where we can actually share concerns, and have a type of document that can be implementable and applicable across various types of missions. So in 2019, we actually kicked off a European working group led by ESA, but with European participation. And we are currently in the process of releasing the first technical guidelines on safe rendezvous and proximity operations. We also had the coordination with various groups. For example, the European Operations Framework, the EOF, also confers was also aware about what we were doing. Whatever work that was done in this working group was also made publicly available to the ECSS working group, the Space Traffic Management working group. That is actually the European forum that has the relevant importance in terms of coordinating this type of activities. And I'll explain a bit later how we are actually interacting with them. This is just a big picture of to give you a timeline perspective about the activities that were done since 2017. And in the next slides, I'm going to go a bit in more details about what we actually did and how we implemented the best practices and the technical guidelines. So as I mentioned, the first step was ESA internal. It was quite a long process in order to actually provide technical input for future design principle on the cross proximity operations. And as I mentioned, the main idea was to, or the target was to support industry with technical guidance and also identification of potential licensing methods, because also some licensing authorities came back and actually asked what would be our the technical feasibility in some cases. We also wanted to capture the knowledge from the experts that were part of various missions, for example, ATV missions, all types of maybe human-rated missions internally at ESA. So their experience was considered very valuable for the work that was done internally. The main goal, as I mentioned, was actually to protect the orbital environment and other assets in space. So safety and actually sustainability of space activities, and also to also see how we can enable international engagements. For example, the observer role that we had in conference was also an enabler for international agreements, and also the fact that we try to make our document available publicly after we released it. So what I need to mention also is that the initial technical inputs that we had, so or design principle document did not include the servicing operation phase. So for example, refueling, this type of operations was not initially included. You can see here a bit of expertise inside ESA, what type of experts were part of our working group. We did not include at that point also legal aspects, because the feedback that we received was to set up first a technical backbone for the activity, and after that the legal will follow. And we are still in this process of actually setting up the technical base first, and after that following up with the legal aspects. In order to actually come with the technical note on safe proximity operations, we had to develop our own methodology in order to basically prescribe how to perform rendezvous and proximity operations in a sustainable way, again for non-human rated missions. So the experience with the human rated mission was very much appreciated, but we had to take it a step back, because we were targeting specifically non-human rated missions. First, we had to define the mission concept, and for this, we had to basically go into the boundaries of applicability and to define actually the applicable mission types. We also had to define the phases, and this got, of course, very technical. And if you can also see the way we are actually split the areas or events and the phases. It took quite some work in order to actually derive this type of common understanding throughout the experts that were part of the working group. So in terms of the of the areas or the events. Basically, we said that in order to perform a rendezvous or close proximity operation, basically you need to have an approach ellipsoid, which we defined as a zone between which is necessary to measure the relative velocity between the servicing vehicle and actually the target in order to avoid collision. We had to define also a keep out zone, which we thought as a zone around the target in which the servicer has 6 degrees of freedom, and the point of no return. Basically, there's the point or the moment in time at which it's safer to continue with the capture or with the rendezvous, rather than to perform a capture avoidance maneuver, a collision avoidance maneuver. And this was agreed among the working group. And basically from this, we actually defined the phases. This helped us later in order to actually prescribe some design principle and actually technical guidelines based on the phases and targeting areas. So this was very important for us in order to have this set up clearly and to actually agree on it as a first step. In terms of phases, we have a target phase, we have a far rendezvous phase, we have a close rendezvous phase, a capture phase, a stack configuration when actually the servicing vehicle and the target are actually bond together, and a separation in cases needed where there's no actually mechanical connection between the servicing vehicle and the target. After the mission concept phase, we went to the next part, which is actually defining the interfaces and the actors. And for this, depending on the mission type or on the activities that need to be performed, basically we had to define a launch segment, a space segment, and a ground segment. And of course, this helped us understand how many actors had to be involved, what is needed also in terms of launch services, what is needed in terms of ground segment, and what type of parts the space segment has to have. So the satellite itself, in order to perform the activity that it's designed to perform. The third part was basically to define mission critical events. And this was initially started as a type of brainstorming for the worst case scenario. So basically, what type of activity the space servicing vehicle would provoke in order to, and what would be actually the triggering condition, what would be the source of the hazard, in which phase this type of hazard was produced, and what was the effect. So a type of what if scenario, and for which we could also add the type of failure, if it's random, if it's systematic, if it's both, what type of mitigation principle would be needed in order to actually avoid this type of accident. And also if there can be derived, there are some generic principles, design principles that can be derived in order to actually mitigate. And this type of brainstorming activity actually led us to define the mission critical events and to actually think what could happen. And based on this, actually, we were able to go to definition of the design principles. First, in order to avoid actually that the mission critical event happens, you have to have something on board that actually prevents and mitigates the worst case event to actually happen. Of course, for this, there were a lot of international standards that were checked. Also, a lot of experience that was taken on board based on other missions, and also this is also the moment when the experience from the ATV, from the missions, human rated missions was taken into account. And also there were a couple of CDF studies, so feasibility studies that were done in order to to actually also help with this type of mitigation measures, and to actually from this to generalize. And this is how the design principle were derived. There's a whole methodology document that is backing up this type of final version of the design principles. And if anyone is interested, you can also message us. We can make it available. The design principles that we actually derived were put together in a technical note that was released in 2018 as a safe close proximity operations technical note that was made publicly available to the industrial partners that were, or the stakeholders that were interested in actually understanding our methodology and also our approach in deriving the guidelines. Of course, after the distribution to various European companies mainly, the feedback that we got was that the document also is very technical, and for some requirements or guidelines, it's quite difficult to assess actually compliance and applicability for various missions. Also, we got feedback that it is not clear how to perform verification of some requirements. For example, when we have probability of collision with the client, some tools of course exist, but we also have at the moment no way of actually verifying how you could perform the verification and the validation of other requirements. So this also made us very much aware that there is still a lot of work that needs to be done, and this was also the reason why we were ready also to go to the next step in order to go on with the work that has been started. In the meantime, also in the US, also everyone was talking about the DARPA consortium, and after that the CONFIRS initiative, which basically is the Consortium for Execution of Rendezvous and Servicing Operations, which was created with the goal actually to develop technical standards for safe on-orbit rendezvous and servicing operations, and to actually establish the rules of the game for this type of operations, which again everyone was aware that is needed, but there was nothing actually that could prescribe what needs to be done for this type of operations. Also, this would enable, according to CONFIRM's, international cooperation and also international engagement, and also would streamline the commercialization of missions, because there will be already a technical foundation that everyone would adhere to. So quite the same type of principle or goals that also the working group internally at ESA had, but of course with less visibility at that point, because it was only meant to actually understand internally what are the technical difficulties and what would be the technical way forward in order to actually start activities on rendezvous and proximity operations. This led us to actually step 2, which started in 2019, and it's ongoing also as we speak. We created a European working group with the objective to derive a set of European technical guidelines, having as a starting point the technical note that was previously done internally at ESA, and also to involve the European stakeholder and try to actually find a common base or common field play, as we like to call it in the European working group, in order for everyone to be involved, everyone to be heard, and to find a way that doesn't actually put barriers to any type of missions and makes everyone aware about the challenges, but also about the opportunities and the things that need to be taken into account, for example, from an operator point of view, from a licensing authority point of view. And later on, we are also looking, we are hoping to have also a legal point of view for this in order to complete somehow the circle. So in 2019, we started this European working group, some of you or most of you are already part of the working group and the sessions that took part. And basically, the idea of the working group is to have at the end a European technical document on guidelines for safe close proximity operations. And who knows, maybe also to go on with the handbook on close proximity operation. These discussions are already ongoing at ISA in order to see how we can actually do this. The working group was led by ISA and involved the European stakeholders. This was on a voluntary basis, and also whoever was interested was very welcome to participate. We started the activities in December 2019. And the main objectives was to actually exchange information at European level. We had national space agencies, system integrators and suppliers, operators, insurers, and universities. On the right hand side, you can also have a quick overview about the members that were part of all our sessions so far. We aim to actually revisit the boundaries of applicability to actually define a close proximity operation glossary that is well understood and actually well accepted by all the parties. And the scope was to prepare the safety and sustainability guidelines, technical mostly for non-human rated missions, including rendezvous, but up to capture. And also to provide the visibility of the results of the working group to the European space community and to the European space industry, and to contribute to the development of the worldwide rendezvous and proximity operations and on-orbit servicing implementation standards. And for this, of course, the technical guidelines that we have are already part of the space traffic management ECSS working group, and they are aware about the work that we are doing for the technical guidelines. So far, we had 5 sessions with a kickoff in December 2019, where basically we in different times we kicked off live. And we had basically the definition of the terms of reference and roles and responsibilities. We had another session face-to-face also in February 2020, where we actually consolidated the term of reference, and we had an overview about the close proximity operations activities from all the members that were involved in the session. So just to give you some example, Thales, Alenia presented their activities, Airbus, various space agencies, CNES, DLR was also present, CNR, GMV presented their activities or the work that was done internally. OHB was also there, and also they presented their activities. And whoever had any other later presentations, we also included them in session 3. For the session 3, we started discussing the technical requirements for general guidelines applicable to all phases for rendezvous and proximity operations. Basically, we followed the structure that was already part of the technical note that was released in 2018. In session number 4, we actually went on and discussed specific guidelines for target, rendezvous, far rendezvous, close rendezvous, stack, and separation phases. After that, in March this year, we released the first draft of the guidelines on safe close proximity operations. And in session 4 in May, we actually discussed the technical guidelines based on the feedback that we got, another round of feedback from all the stakeholders involved. And we are actually now updating this technical note and planning to release the final version in July this year. So it's just a couple of days away. Just to give you a flavor about what was discussed, for example, in the second session, we received quite some feedback from stakeholders. This we took into account and we discussed plenary. This is just an extract of the technical requirements. If you are interested, of course, in how the requirements evolve, you can always contact us, and we can make the publicly available version also available to you. Just to highlight a couple of conclusions and next steps. Basically, the European Close Proximity Operations Working Group, again led by ISA with European participation, has proven that the exchange of information and actually the participation of the European stakeholders is is giving an opportunity for everyone to exchange information and to ensure that everyone is heard and involved in the technical discussions. Doesn't matter what type of missions they're having in mind, even if it's a small mission demonstrator, even if it's just a proof of concept or maybe recurrent type of satellites. Everyone was feeling welcomed and involved, and this is the feedback that we got from each of the sessions that we held so far. The outcome of the discussions is captured on the technical note that I mentioned, Guidelines on Safe Close Proximity Operations, that was released as a draft in March this year. And basically the idea of this document is to present the technical understanding and also the agreement of the European stakeholders on close proximity operations to this date, and also to serve as a baseline for the future technical discussions. And as I mentioned, this document is going to be released as a first issue this month. So stay tuned for the news. Regarding the next steps, of course, the working group highlighted the fact that there is still a need to actually discuss some of the requirements that are a bit more sensitive or that they are causing a bit more that they need an extra thought, so that we didn't manage in the 5th sessions that we had so far to actually completely grasp all the technical understanding. So it was suggested to actually have this this handbook on close proximity operations and go on more details regarding the rationale of the requirements, the method to assess compliance, and also the tools that can be used if they are available or if they need to be further developed, and also the mitigation measures that have to be adopted, with giving some proper examples about compliance and mitigation measures, because of course there are different ways to assess compliance based on the different type of mission and applicability. Of course, a way forward is being discussed internally at ISA in order to understand how to elevate the technical note to an ISA handbook. And also an ISA handbook that, of course, will be made available to the Space Traffic Management Working Group. And just to give you a bit of a background information, this ECSS Space Traffic Management Working Group already exists, and the rendezvous and proximity operations on orbit servicing standard is part of the Space Traffic Management Working Group. So whatever technical inputs we have, we will make them available to this working group that is actually holding meetings a couple of times per year. The next session actually of the European Close Proximity Operation Working Group is planned to be in October, November, and this is when this selected set of requirements will be further elaborated, and we'll discuss further regarding rationale, mitigation actions, and verification methods. And thank you very much. This was the presentation that we prepared for you for this afternoon, and I think we can open now the floor to questions.
Thank you very much, Adina, for the presentation. Thanks for also being able to summarize in a short time the complexity of this topic. I don't know if there are some people who want to ask some questions at the moment. Some questions are related to the membership of the working group. If you can just say something on how they could be added to the distribution list and participate to the discussion.
So far, how it worked was always on a voluntary basis. You can always send us an email, and we will add you to the distribution list, and we'll make you aware about what are the next steps, what is happening, what are the official documents that are distributed, and also you will be invited to the next session. So There's no membership fee. There's no commitment to actually participate to all the sessions, but you're always welcome to contribute, to listen, and to of course be part of the sessions.
Adina, there was also another question. I don't know whether you can reply, or maybe Lorenzo, if he's still with us, could help us. It's a question on the ISO standard that I'm not very familiar with. It's quoted TC20 sorry, there's Lorenzo, maybe you can you speak up, because you have the reply to the question directly. I think that basically my understanding is that there is no ISO standard at the moment covering close proximity operation. There is a working group which has been set up to derive the standard, but the standard is not available yet. The space debris mitigation standard does not cover close proximity operation, but maybe this is, I don't know if this replies to the question or if we need to go deeper on that.
Basically, there is the ISO standard, the 24330 rendezvous and proximity operations on orbit servicing. That is, as far as I'm aware, but maybe someone that is part of the meetings on standardization can help us further. Is not fully approved. I mean, it is under discussions. There are several feedback meetings that are happening in order to improve it and make it more solid, but there is not an official stamped one.
Yeah. Excellent. So everybody is confirming that it is something which is ongoing but not finalized yet. So our technical note can be seen as an input to this ISO standard, but I guess that as is, this will be channeled through the ECSS working group. That's the role of the ECSS working group, from what I understand. So we are in line on that. My understanding is that possibly with the work we have been doing, we are a bit more advanced on the technical description of the different phases than others are, but I might be wrong. Adina, I was wondering whether you could give us a couple of examples of technical guidelines on which there is already an agreement, and some of which there is not yet already an agreement, and we need to go a bit deeper.
Yes, for sure. I can give you a couple of examples.
So while Adina is digging this out, let me do a kind of a small introduction. From what was our understanding, there is no standard on close proximity operation. On the other hand, close proximity operation can be dangerous and creating debris, and therefore both the companies performing them and the licensing authorities need to check on the safety of these operations. Everybody is deriving his own standard. ESA has all the description, all the mission requirements, we can derive them thanks to our background. But the idea was to try and be more transparent and have something which is agreed or discussed among everybody. And as always, while everybody agrees that the close proximity operation should be done in a sustainable, safe way, not creating debris, the moment you start to say, what does it mean? We get in trouble into the definition, and that's it's a very long, and let me use this word, sorry, Adina, tedious work on which you have to be extremely precise. So maybe with a couple of examples, you can describe what kind of work the working group has been carrying out.
Yes, definitely there were some requirements that gave us some headaches. We still had I think 2 or even 3 sessions when we discuss it, and we are still not totally fully convinced that whatever final version of the requirement we have is still a final version that can be fully verifiable, that can not impose basically a design solution, because that would be the thing that we do not want from a requirement, because imposing a design solution, meaning that all the missions are going to be constrained to actually apply a design solution for that. And basically, because of the participation of the working group, where we have various European stakeholders from big to small, we are actually constraining or putting more effort into some areas where, of course, not everyone agrees that it needs to be done this way. And one of the best examples is actually how to actually avoid a collision between the space servicing vehicle and the target. And one of the requirements that we had, and we are still discussing about it, is basically if the system should be 2-fault tolerant or should be 1-fault tolerant, and actually with a probability of collision that goes back to space debris mitigation, and actually a way of calculating and doing some analysis based on what we already know from space debris mitigation with the 10 to the minus 4, for example, or do the 10 to the minus 3 with the internal breakups. So this is still a requirement that gives us some headaches, because being 2-fault tolerant, meaning actually implying some extra redundancy. And of course, for some in-orbit demonstration or for some small mission, this implies extra cost, extra complexity, and maybe is not actually needed. And of course, from an operator point of view, they'll be more comfortable with this, because from their point of view, if you have more redundancy on board, of course, it's more somehow safe, or actually it goes through several checks, and for them, it's a mission that is more reliable. And this of course created all types of debates in the working group, and it's still giving us quite some room for discussion. And this is for sure a good candidate for a session in October, November, in order to actually come with some concrete examples on what is the rationale, what is the mitigation measure, what is the way to calculate, and what type of tools do you need in order to prove that you're actually safe and you are doing something that is sustainable on the long run. For some others, for example, that we need to, when we actually are performing the rendezvous and proximity operations, we actually need to have some type of information from the activity, and even if it's in a form of, I don't know, pictures, data, some type of information needs to arrive on ground in one form or another. And this everyone agrees. I mean, it's a type of operation that is new. We don't know a lot about it, so some type of information needs to arrive to the ground centers, even if not in real time, maybe stored on board, downloaded after. But of course, we need to find out more. So this, everyone agrees that in one form or another, ground needs to be in the loop at some point in order to actually get this type of data. So that was not really a fight that we need to have, a fight, of course, in quotation marks, that we need to have in the working group, because everyone is interested in actually more data about how these operations are being performed. When it comes to actually the navigation solutions, for example, what do we want to have in terms of information from the target? Of course, this is also creating some type of discussions, because it really depends on the type of sensors that the mission, or the cameras, the navigation solutions that the mission will have on board, the servicer will have on board. And based on this, of course, you have to consider different types of data that you can download, and actually different type of information that you can get from the target. These are just a few examples. I'm not sure if you have any specific questions regarding any type of requirements that or any type of activity, specifically rendezvous and proximity operations, that you want to understand, if we talked about it in the working group.
No, I must say that at the moment the questions were more generic than this. but I think that a lot of people are interested possibly in joining the working group, but they need to get a bit more of an idea of what kind of discussion are being held in the frame of the working group.
For sure, they are very technical. So far, we did not go into any type of legal discussions, any type of licensing, or any type of operating principles in terms of the from the operation point of view, but just what is needed from the servicer to actually perform the required operation. So the discussions are extremely technical. If you do not like technical discussions, maybe this is not the best working group for you. But if you're really a technical geek, then we are really inviting you to the working group because you're going to have a blast.
Okay. If there is no more question, I don't know, does anybody want to unmute and ask directly a question? You're welcome to do so. We still have a few minutes. Well, it seems that either everybody's asleep or everybody's tired. We're getting close to holidays, or you've been extremely clear, Adina, with your presentation, or this topic is so much for geeks, as you call them, that there is no point in going in further discussion. Just to say, we are open as ESA to have on board to involve you in this working group, and our technical note can be distributed outside, not only to European but also non-European. As you will see, it's quite technical, and of course it will be made available to groups like Confers, the ISO standard, the ECSS. It is supposed to be an entry point for all this discussion. When needing to operate, there are some questions which are more legal, linked to the legal part of active debris removal, but this has been treated in another frame, and I think we will need, in case, to organize a legal webinar. Jessica, maybe this is a point we can take on board to again describe the legal complexity of touching a debris which does not belong to you. But Jessica, in the meantime, if you don't mind, and if you can be quick enough, I think we have in our blog post some specific links which describe all of this, that describe the responsibility of a launch state and what's going to happen when you touch an object which does not belong to you. Jessica, do you think
Yes.
you can post them in quickly in the chat, or
I think so. Give me just 30 seconds. I should have it here.
Okay. So
maybe while Jessica is preparing the links to let you know also that after we had the first draft available of the technical guidelines, we also made it available to our legal expert internally at ESA, because his advice initially was first to set up the technical basis for what we need for what we want to put together in terms of guidelines and design principles. And after that, they will take it on board, have a look, and come back to us with the legal aspects that need to be taken into account for this type of operation. So for sure, they had a look at our previous technical note in the past, but now they're having an extra look in order to understand if there's anything that needs to be specifically taken into account, and also how to further approach it for the next step, maybe of adding the legal aspects.
So yes, and just to complement what Adina is saying, we had tried to involve since the very beginning, our legal colleagues, but the first point, they came and said, can you please specify a bit better what you are talking about? What does it mean, close proximity operation? And already we got stuck on what does it mean, and that's the reason why we went into all this kind of technical description on redundancies and phases and all the rest. And now, on the basis of this, we hope that they will be able to support us on the legal responsibility. So thanks a lot. We are very much on time, 1 minute to go. Adina, everybody is thanking you on the chat for the great presentation. Thank you.
Well, thank you for being available, and keep an eye on the next webinars.
Yes, and also, Adina, I think that we will publish a blog post when the technical note is going to be available in the month of July, correct? So
Yes.
keep an eye on our blog, because there you will find the link to the technical note once this is available.
Thank you very much, everyone.
Thank you. Bye.